I believe this is one of the most impactful problems of today and the future, and we need to build it ahead of time.
We're like in this situation where we have basically an oligopoly forming at this layer, where there's like a few big companies that are effectively the only ones that can train these models today.
What we are working on would be to utilize all the GPU resources in the world to train the biggest, more powerful model in the world.
What if I make my model open? Like, what are my incentives for it? Like, what do I get? Nothing. So I don't have any reason to make it open. And there's a really good way to solve this problem.
If you want to truly enable people to contribute data to the model, I think you have to go fully decentralized and go full consumer grade hardware.
My prediction is that we're going to have decentralized AI summer 2025. You heard it here first, and I'm looking forward to seeing all the incredible progress you guys are making in this field. In recent years, a burgeoning ecosystem of projects working on open source development of machine learning have emerged. And among Web3 innovators, it's clear that the ethos of crypto should apply to AI. Still, there's one non-consensus narrative that's proliferated throughout decentralized AI, and this is decentralized training. While some claim it will never work or it's not a relevant problem, others believe that by taking the time to advance the state of the art of decentralized training right now, we will actually solve a number of interesting problems in AI broadly and will enable a level of open source innovation in AI that will result in the democratization of this incredible transformative technology. This group that we've gathered today is composed of companies whose founders are some of the most experienced AI researchers, developers, and operators in the world who happen to be in our portfolio. CoinFund's thesis on decentralized training is reflected among their innovations. And while decentralized training to some is a far-off technical problem which may never be solved, to us it's an incredibly important approach to lowering the barrier to entry for modern AI and avoiding its monolithic control. It's never been a more exciting time to be on the intersection of AI and Web3. And the best part is that this supposedly impossible technology is already being built and is already going to market. The goal for this conversation is to provide a thoughtful forum for decentralized training and shine some light on the skepticism and innovation happening in this space. We want to get closer to the truth of decentralized AI innovation and how our portfolio companies are working to contribute to the realization of open source AI development. Let's welcome our portfolio companies to the roundtable. All right. Welcome, everyone. It's November 2024. We've been living through a few years of incredible innovation in the AI space. We're currently in San Francisco in the Presidio, which we might say San Francisco is the epicenter of modern AI right now in the world. We're also very excitedly watching some of the developments in Web3 and how Web3 is merging with the AI space. Each of you guys represent companies in the CoinFund portfolio who are working on this intersection of AI and Web3. My name is Jake Brukhman. I'm the founder and CEO of CoinFund. And I would love for maybe each of you guys to go around, introduce yourself, give us a little bit about your background, and tell us what you're working on in which area of decentralized AI. Bidhan, we'll start with you.
Yeah, for sure. My name is Bidhan. I'm the founder of Bagel. And Bagel is working towards making open source AI monetizable. And there are different verticals to that we're solving as a problem. And my background is engineering. I've been an engineer my whole life. I used to lead a team at Amazon, which was managing the machine learning infra of more than 100 million Alexa devices around the world. And been at lots of other different companies and kind of gathered the experience in Web2 AI and machine learning and kind of stumbled on this problem that needs to be solved really badly. And yeah, excited to be here today with you guys.
Awesome, thank you. Johannes?
Yeah, I'm Johannes, one of the co-founders of Prime Intellect. And yeah, what we do is we basically aggregate global GPU supply from all providers, all data centers. And we work on research to make it possible to do decentralized training across different clusters of GPUs. And yeah, all kinds of other research to make open source AGI reality. So a couple of other research directions we've been working on internally. And to my background, I've been mainly coming from the AI side, have been working as a AI researcher at a foundation model lab in Europe, and
Jeff Amico from Gensyn, the Chief Operating Officer. Gensyn is building the world's machine learning compute protocol. We aggregate compute and make it available to researchers and developers who want to train high-scale models at low cost. My background, I began my career as an attorney, as a corporate lawyer. Found my way into the blockchain and crypto space through that kind of that pathway. Spent the prior 4 years at A16Z on the early days of the crypto and blockchain team over there, and then joined Gensyn about a year and a half ago to become COO.
I'm Ahmed Rashad. I'm the founder of Kiva. We work on frontier data. Our thesis is that data is one of the most telling factors of how good a model is going to perform. And we try to make this data more valuable. We try to aggregate it, collect it, clean it up, add human insights to it to make the data much more valuable. And now it can be used in more niche applications. The future of AI, we believe, has to have a human factor, and we add that human factor. I actually started my career as an offshore oil driller. And then I tried to solve a problem while working on the rig, learned how to code, built a product, and became a software guy about 20 years ago. And ever since, I've always been going after the problem. You go and try and solve a problem, and you realize there's a bigger problem behind it. And that's the way it's always been, and that's how my career has worked through my time at MIT and then McKinsey and Amazon, and also Scale AI before this. And here I am today because I believe this is one of the most impactful problems of today and the future, and we need to build it ahead of time. And I think there's a lot of synergy that's been overlooked in the past that Web3 can bring to this problem specifically. And I think this is going to be the solution of the future.
So Alexander Long, founder of Pluralis Research. We're working on large-scale model parallel training. We view this as very important to have a third approach between current paradigm of open source and the sort of centralized API vending that happens today. So the collaborative training of large models, which you can actually incentivize if you can monetize the model layer. And my background is all trad AI. So I did my PhD in non-parametric external memory and deep learning. And then I joined Amazon straight out of that, where I was working on multimodal foundation models for 3 years, and then started Pluralis in March this year.
Awesome. So maybe one thing to mention about how we at CoinFund think about investing in decentralized AI. Our modus operandi is to take founders like yourselves who are pretty experienced in the AI world. Some of you, actually many of you, have worked at Amazon before. You've been in production, including myself. Didn't work on AI at Amazon, but that's true. And you've all recognized that bringing Web3 primitives to whatever aspect of the problem you're working on is really important. It's transformative. It's democratizing. It creates better openness, better open source. And then the goal is to take these products, which are presumably better, and to compete with what's in the market today. So in other words, compete with AI that is in Web 2. And that seems like a hard problem, especially when we start to talk about training in a few minutes, right? OpenAI, people say, is already so far ahead. But before we jump into that, and you guys have all kind of alluded to this already, I just want people to be very clear. What do we think are the key value propositions of decentralized AI? Why are we going so headlong into a number of really hard problems here, right? Why are those problems worth it? Does anyone want to jump in?
Yeah, I think the problem at the moment is we're not on this path. We're in this situation where we have basically an oligopoly forming at this layer, where there's a few big companies that are effectively the only ones that can train these models today. They get to dictate the behavior. They get to dictate the access. They have not just large amounts of economic control, because these things are very valuable, but they have a large amount of cultural impact and control. Like one example I always like to say is like if we have this AI tutor scenario where like most people are learning most things through interacting with software that like at the base layer has a dependency on 3 to 4 foundation models, like to me that's almost dystopian, right? It's like every encyclopedia, internet article, book was written by the same people or edited by the same people. And so I think it's clear that we need some level of alternative to sort of what's happening here. You know, we'll probably talk about it more, but I think open source today is not equipped to provide that alternative because it would require sort of the donation of huge amounts of compute, right? Rather than just time, as is like the case of normal open source. And so there sort of has to be this third paradigm of like some kind of large scale decentralized training that comes with some level of ability to like incentivize that training.
Mm-hmm. Anyone else want to jump in on that question? Why? Yeah. What are the value props of decentralized data?
Maybe beyond like also cultural, ideological reasons that are really important, and one of the main reasons, obviously, the other one would be on the technical side. We actually need access to the most amount of compute, right? And by utilizing all the GPU resources in the world, you can get more access to compute. Yeah, that's why all the big labs are currently looking into it too, right? Like Google, where they initially published a lot of the research in this domain still, right? Yeah, is looking into this too, to make it possible to train across their different clusters, to utilize all the GPU resources they have internally, right? But yeah, the open source AI community and yeah, in general, what we are working on would be to utilize all the GPU resources in the world to train the biggest, more powerful model in the world.
I think the future also, AI applications are going to get more and more specialized, and they are going to be touching almost every aspect of our life. They're going to be touching medicine, they're going to be touching law, they're going to be touching computer, software, hardware, robotics, et cetera, et cetera. And to your point, it's incredibly dangerous to, one, have it all in the hands of a handful of companies, and two, I don't think it will work because it's so fragmented. How much can a big company focus on the super fragmented areas? You need to open it up. To open up, one, address the existing areas that need to be addressed, and two, to actually discover new areas. So there's a role for centralized. I'm not saying centralized is all bad. There's a role for it, but now I think it's the time for, let's open it up to the public and let's see what can we get out of it, and let's see the efficient markets work, where people are going to see a problem, they're going to go find solutions for it, instead of a bunch of researchers who are great sitting and deciding this is what we're going to do next.
I agree with that. I think it comes down to creating the incentives and the structures such that there can be real competition in the space beyond just 2 or 3 companies. I don't think there's been a prior wave in computing before this that has been this concentrated among big players. It would be as if the internet was, all of the websites on the internet were created by 2 companies, right? As opposed to this rich open ecosystem of, you know, this kind of explosion of creativity that only comes when the barriers to entry aren't as high as they are now, right? And so you look back, a lot of what enabled mobile and, you know, the web itself were innovations in the underlying infrastructure and the underlying computing infrastructure that made it cheaper, such that people don't need to either stand up their own kind of, you know, computing stack in-house, or, you know, other aspects that allow just the developers to focus on, you know, moving a little bit further up the stack without having to build and pay for everything that goes below it. So I think the same thing is critical here.
I think you bring up a really interesting point about, you know, openness and what does openness mean, and I just want to make this point now. So, like, you know, we do hear a lot about open AI today, right? Like we have kind of stability AI launching generative models that are basically, you know, open weight. We have Llama 3.1 now with open weights. But when I think about true openness, when I think about open source, like what's the first thing that comes to mind? It's like GitHub, right? I think about going to someone's repository, being able to read their code, and with one click, I'm able to fork that repository and improve upon the code and actually like launch a competitor to whatever that they're doing. It's in blockchain, in the blockchain world, that's known as forking. And in GitHub, it's known as forking. Well, what we don't have in the AI production world today is forking. So when you talk about lowering the barrier to entry, I think about that as openness, where someone can come in, and have enough information from a model creator to be able to like one-click fork them and then reasonably be able to compete with them.
Yep.
And that's the true definition of openness. What we have today is open weights. And that's not as open as what I just said. Because when you have open weights, that's great. You could do a bunch of research, you could run a bunch of experiments. But what you don't have is knowledge of the data. You don't have knowledge of the setup. You don't know which hardware exactly maybe it was trained on. And you can't reasonably compete with Llama 3.1 today. So we're thinking about changing all that. Any other thoughts on value propositions?
Totally agree, like what you just mentioned. The forking basically means like collaborative work on shared projects, right? And we don't have that infrastructure today in AI. And one of the bigger reasons we believe at Bagel that why that doesn't exist is that there's no specific monetization mechanism for all those things, right? What if I make my model open and there's a competitor who are building on top? Like, what are my incentives for it? Like, what do I get? Nothing. So I don't have any reason to make it open. And there's a really good way to solve this problem. Like, cryptography is like one of the technologies which solves this problem really well. And that's where I feel like cryptography comes in and contributes to the broader AI ecosystem and solves one of the bigger issues that's kind of stopping us from going to the future that Jake just mentioned.
Great. Okay, so now I want to jump into the main topic, which is decentralized training. And to sort of get into it, maybe I'll start with you, Johannes, because you're someone who I think has had some experience training models. Just for the audience, like, what's that experience like? What does training models entail? How long does it take? How much money does it take? Like, what could go wrong?
Yeah, for sure. Maybe we start with the centralized setting then. And yeah, how it's usually been done, right? And like you have a large A100, H100 cluster to train your foundation model. It's usually 24 months at a time to do a pre-training, right, of such a foundation model. And there are different techniques, right, to actually like parallelize the workloads of your GPU training across those different clusters in a centralized setting, right? Where you have like data parallel approaches, where you train your model on like different GPUs independently, right, and sync every step, or even model parallel approaches where you split up your model. So, yeah.
Anyone else want to add to model training experience? Like, what is that experience like for people?
Maybe I'd just say, like, it's still very much an art, right? The stuff is like, okay, there's like very deep theory here, but when you get in the practicality of training, like, you got to train it a bunch of times and you realize like kind of what works and you almost get a feel for it, right? It's much more of like an art than a science today, I think.
Yeah, how it works today is that like there are these large clusters and there are these scientists and engineers who are kind of overseeing it. And a lot of the times, like, they get a result and they have to just throw it out. Like some computation that was done for the last couple of days, for example, that cost a lot of money. So it's, I agree that it's more of an art. Like, you got to figure out like what works and what doesn't. And that intuition is what kind of builds towards the bigger solution.
The way I sort of understand it is, you know, to get to the level of intelligence in AI that we have now, people had to do something, people had to make a bet that basically we have to gather a large amount of data and a large amount of compute, we're going to train a large model, and we're just going to make a bet that if we do that, that model is going to become really intelligent. And so, you know, prior to efforts like that, it wasn't really common to have a data center of GPUs for something, right? And so people did the simplest thing that they could do to make that work. And there's not, like, it's such an early stage in the development of how AI models are trained at scale that there's actually like a lot of different open problems surrounding that. Like, how do you make a data center robust? Or how do you interrupt a training, you know, in the middle but not lose all of your work? Or like, what happens if a machine fails? You know, does that mean you have to start all over again, right? And a lot of these problems maybe are solved locally within kind of private companies, or they certainly have to deal with them. But these problems are especially prominent when you go from that centralized setting to a decentralized setting. And so now I want to talk about decentralized training, right? Like when you would say these words here in San Francisco 12 months ago, you would be met with a lot of skepticism. So can someone explain, like, why is this such a controversial topic? Why do people not think it's going to work?
I want to sort of explain why these like models are trained to use the high bandwidth interconnects in the first place, because I think it's kind of interesting, right? So AlexNet, like the first big neural net, weirdly was actually pipeline parallel. It was like a two-stage pipeline parallel, right? Because back then, I think the biggest consumer card was like an 8 gig card.
You had to
none
split
of
it
the
up.
none of the quantization was there. Like everything was full precision weights, and so Alex split it over 2 cards, and sort of just manually hard coded the whole thing, right? And then like that stopped, and everyone just was doing data parallel, because I was like, okay, we can actually fit the thing in a card, but we want to sort of put these batches through in parallel, and we have this big all reduce at the end. And so that sort of paradigm was like, okay, we need this fast interconnect to do these all reduces, right? Like that's how it starts. Then at a certain point, it's like, okay, now the models are starting to really get big because people started to realize like the scaling was working. We should split them across the accelerators. Well, we already have these fast interconnects for the all reduce in the data parallel setting. Like we can use that. And then at the same time, like, you know, you had things like tens of parallel, which were like, okay, we have like even faster. Like we have these like NVLink things, right? So like, the point I want to make is like the algorithmic development happened like in parallel with sort of the data center build out, right? Mm-hmm. Like it was aware of the topology of the underlying substrate, and it's linked, right? Some of the algorithmic decisions, like you would never do tens of parallel in a decentralized setting, right? Because you don't have the NVLink. So yeah, I sort of think that's like some important context is like these things.
There's a certain, what you're saying is that there's a certain path dependency
Yes.
with how research proceeded and how hardware proceeded.
And they interacted.
And they're reflexive of each other.
Exactly.
It creates a feedback loop, and one where the kind of way we train models feeds into the way we build the data centers, which then feeds back into the way we're training the models.
Exactly.
It's clearly led to this suboptimal local minima, wherever you want to think about it, where we're stuck because people think the only way to train these things is the highly synchronous, super fast bandwidth between the nodes. So we keep making the models bigger. We keep making the data centers bigger and bigger and bigger. Clearly, we're at the limits of what is feasibly possible with that approach.
When your customers are like big tech companies who are demanding a centralized setup and centralized control, then the hardware providers are going to like keep going down that.
It was the
path,
easiest
going down that
way
direction.
to scale from, say, 2017 to today. Just make the model bigger, make the data bigger, make the data center bigger. We're now hitting the limits of what is actually possible. And I think we can talk more about this, but I think we're also seeing potentially limits of the architecture itself and the data and things like that as well.
So a couple of thoughts on that. One is, of course, the hardware builders are going to follow whatever gets them the most revenue, right? The most profitable revenue. And it's, of course, companies who are big in tech are on the forefront of this. They're going to hoard most of the resources. But again, to the point of they cannot do everything. No single company, I believe, could or should try doing everything. And I think the future is going to be a lot of people trying a whole lot of different stuff and efficient market dynamics taking place. So now I think we're at this inflection point where things are probably going to start changing on actually how do we serve this disconnected, this decentralized world, the new world where AI needs to head. And the hoarding of resources is going to start going down a little bit because this new, really efficient, really hungry market is going to start to become a necessity, not just going to start to surface, it's going to become a necessity. Now, this same trend, and I'm predicting this because we see the same trend in, for example, in data collection very early on in the process. In the beginning, if you were working in data collection, it kind of didn't make sense unless you worked with big tech. They have the money, it's shorter procurement cycle, all of those things. So where am I going to go? Of course, I'm going to sell to them, right? And they're going to take all my capacity and then leaves nothing for everyone else. So that's the main thought, that we're at this inflection point of if we actually keep pursuing this path, way more efficient ways that serve this decentralized model are going to have to start evolving because it's more or less an efficient market. The second thing is, because of this centralized, proprietary, closed doors way, what we see in the barrier of entry keeps getting higher because everyone's trying to solve exactly the same set of problems over and over and over again. In open source, you don't have to. I can take whatever, like Llama 3.0. I can take not Llama 3.1, but I can take your model, build on top of it, compile it with a bunch of other things, and create something completely new. But I don't need to solve all the 20 things he solved, or the 50 things he solved, or the 30 things he solved. So I just build on other people's work, and now we have a number of efficient layers that are hyper specialized. And you only need to go the last mile instead of having to drive the whole way, each and every one of us having to drive the whole way to develop an AI application that works.
Great. So, like, it sounds what you guys are kind of saying is like the reason why decentralized training might have felt impossible to a lot of people is because their mental model is this like data center model that's really meant to feed into big tech companies, essentially. And if you take a step back in the evolutionary tree of technology, and you sort of change your assumptions about who your customer is, to your point, Ahmed, right? Like if you say, well, now my customer is going to be a decentralized network with many different nodes, run by many different people, with maybe like not high-end hardware, but maybe commodity hardware, we can have that conversation. Then the problem set for decentralized training becomes different. And maybe I'll go to Jeff now, because Jeff, you published like a really thorough Twitter thread on behalf of Gensyn, kind of explaining how far we've come with some of those algorithms and what are still the challenges that are left to tackle there. So maybe you can cover a little bit of that.
Sure. So just to set the stage, as Alex was mentioning earlier, the way that we have scaled these models means that they no longer fit on single GPUs or even within single nodes. So the kind of progression has been, first we start with splitting the model across devices. Then, from there, if we want to kind of scale up the speed, we can also scale up more GPUs to kind of train on different batches of data. Training on different batches of data, what's known as basically data parallel, is so far the most communication efficient because the different nodes are effectively all storing the model, kind of in its entirety within their node. They're training on different sets of data and then are only synchronizing, only kind of communicating with one another at some kind of infrequent step. So a lot of the kind of early work in decentralized and distributed training so far has kind of taken that general approach. So, call it data parallel. There's different methods within that kind of label, but every single node across the network is all storing the same full model weights. They're all training on a different batch of data. And then at some infrequent interval, they're talking to one another to keep the kind of model weights and the updates synchronized. That's great, and I think it's an amazing first step. And Johannes, you can definitely talk more about the work they're doing on that front. The issue with it is that it doesn't scale all that big because every single node has to maintain the full model weights in its memory. You can only fit a model up to, I don't know, say 10 billion parameters, give or take. That's something on the order of 2 orders of magnitude smaller than frontier models today. While it's still great, it's not going to get us all the way there. And so we need the other category of parallel techniques, generally speaking, called model parallel. So those are where you split the either you split the tensors within a given layer of the model. So effectively the operations, the kind of matrix multiplications that every node is doing, you split those up across GPUs. Or you split the layers across GPUs. So you put layer 1 here, layer 2 here, layer 3 here. That allows you to get over the memory issue, right? Because every node does not need to keep the full model weights in memory. They only need to keep a small piece. The trade-off is there's more communication that has to happen. And so with tensor parallel, you're kind of communicating in every single layer multiple times. It is by far the most heavy communication. The pipeline parallel, which is splitting the layers, is slightly less, but still somewhat difficult. But again, this kind of direction is, I think, the next step to be able to scale models bigger.
Okay, so I want to get to model parallel with you, Alex, but let me ask you, Johannes, if 12 months ago people said this was impossible, I think you guys at Prime Intellect know that it's very much possible because you have implemented a data parallel approach. So can you tell us what you guys have done?
Yeah, to maybe give a bit of a timeline there, basically, right? So, yeah, we started out like with our first research release around 4 months ago with OpenDialoco, where we basically like replicated some of DeepMind's work called Dialoco Distributed Low Communication Training, which is basically an approach where you have this data parallel approach, you train across different clusters of devices, but you don't have to sync at every step how you have to usually do in your data parallel training, but you can get this to like syncing every 500 steps, for example, right? So we replicated their research, did an open source framework for it, and yeah, successfully scaled it to like 3 times the size of what they had in their work, right? To the 1 billion parameter size. And then, yeah, I think like 4.5 weeks ago, we started training a 10 billion parameter model with a similar approach. So we've made some progress there on the algorithmic side of things, obviously, in the meantime, so that we can, like, for example, quantize even more, get even more yeah, communication reduction, right? For those pseudo gradients that we have to send there, as well as like building a new framework basically for fault-tolerant training in PyTorch. Yeah, that we are training our 10 billion parameter model on. So it's the first time basically of like this size basically for a model being trained, yeah, across different data centers around the world. So yeah, it's been training for the last 4 weeks. Yeah, when this recording comes out, it's going to be yeah, published already. It's going to end actually today. The training one's going to be at 100%. And yeah, it looks like, just looking at the evals, yeah, Dialoco is scaling to the 10 billion parameter model size. And yeah, we had a lot of learnings basically, right, on like different fault-tolerant training approaches where it was still failing, right? So it was yeah, has been really helpful to test stuff in prod basically, with everybody being able to join the training runs through our platform where we aggregate all the GPU resources around the world, right? So yeah, now at the end we had like nodes joining from like Finland, from so Europe, yeah, Asia. We had a couple of nodes in India, in Singapore, as well as a bunch of nodes in the US. And yeah.
I was going to say something about the logo. Like something like super interesting in that paper that I remember reading was like, because the logo is basically like an inner optimizer and an outer optimizer, like an infrequent outer optimizer. And I remember reading when they baseline it on a single node,
Yeah.
It does better than just the inner optimizer. And I thought that was like super interesting, right? Because it's like, wow, okay, you like have this different training scheme that you've tried to get to work for the decentralized case,
Yep.
and actually like the robustness is better,
Yep.
even in the centralized case. And we're also seeing stuff like this, right? In the model parallel setting where it's like, oh, it actually almost works better. I was wondering, like, what do you feel? Do you think, like, this is very contrarian, but I'm starting to feel like maybe the models want to be in the swarm, right? Like maybe that's where they want to live. I don't know, what do you think about that?
Yeah, good idea, right? That it's actually, yeah. But I think we're going to find a lot of the things while we are all doing our research that is actually going to help even the centralized training case, right? To make more efficient models, right?
Yeah.
Like if Dialoco scales, it has no downsides, basically. Why wouldn't you use it also in your centralized data center to train your models, right?
Yeah.
So.
Well, say more about the swarm idea, because I think that's an idea that we're excited about at Gensyn too, but I'd love to hear you talk about it.
Yeah. Well, what I meant by like some of the things you sort of almost get as a side effect of this different substrate. Like one very interesting thing is, yeah, there's this paper swarm parallel where it's not really pipeline parallel, it's not really data parallel, so this new thing. And they note in the paper that like, okay, we have these nodes dropping in and out, and this sort of effectively gives us like path dropout as a side effect. And this increases the sort of generalization of the model. And that's something you have to simulate in the centralized case. But in this sort of noisy swarm type thing, you sort of just get it as this side effect of the substrate. And there's just a few things like that you kind of start to see and you're like, this is very interesting.
Curious, like about the prime intellect approach, the Dialoco. Like when like Google kind of wrote about it, and there was a lot of discussion about this needing a lot of hand-holding. No, like there's a lot of eval that needs to be done. And you mentioned evals as well. So I'm curious, like, how are you guys handling the eval situation in a decentralized setting?
Like right now, it's pretty much like your centralized setting to like do evaluations of the model, right? The only thing that comes in with Dialoco in a first step, basically, when you try to train your model, you have a second like learning rate in a sense for your auto optimizer now, right? So it's a bit more tweaking basically on that front, right? But yeah, have seen pretty stable results across like doing a bit of like parameter tuning there, right? Yeah.
Cool.
Yeah. Evals evals are very tricky to do in a decentralized way, because you need the consistency, you need the consistency, you need the volume, you need. It's also an art. So
Yeah.
it's a bit of a science and a bit of an art. Like you're making a lot of guess, and you have to build that intuition. So it's very. I don't know what the answer is. I hope someone can help with the answer. But how do you do evals in a very decentralized way? I think it's quite challenging. We're trying to play with a little bit, trying to decentralize it bit by bit, but it's still further down the roadmap.
We have looked into this eval problem. Like there's that problem that you just mentioned, but there are some other problems too, where like these evaluation data sets, they're just static, and a lot of people, like they just train their model on the static data set, and they get like kind of overfit on that and get like better results in whatever eval data set that you're using. And we have tested using models which generate synthetic data for evals. And like that's actually a composable way to do that. Like the data generated for the eval data set is dynamic. It changes, whereas it's not, the statistical distribution of the data is kind of similar enough.
Yeah.
So that it stays within the eval range, but at the same time, more volume, and also there's like a little bit more entropy. So you cannot just overfit on whatever data set you're trying to eval on your model on.
Yeah, I think synthetic data would help with the volume piece. I think it'll be a great supplement. I wonder how it would solve the actual evolution of the real world and how that's going to be captured, because it's not going to map 1-to-1. It's not going to map even 0.8, right? It's not going to be anywhere close. So, and that's an open question in my mind, is how do we solve that evolution? Because the world is evolving and data is difficult. It's really difficult.
That's similar to the discussions we were having just before this. Like, why don't you share that? Like, what if the models like O1 comes into play, which generates new information out of them, like or supposedly new information? We don't really know, right? We're like, which is not in the training data. And if they're used to generate synthetic data, like, does it actually supplement the real world scenario?
Yeah, we're going to have to test it. To your point, we cannot tell for sure how genuine and new and innovative this data is, and how much does it actually reflect the real world, or if it's forking away from reality. so there are going to be some complications there. But I think the reality is there are a lot of fields, a lot of areas that are not as developed, or not as much work has been put in for AI. Not enough data has been captured. And those fields are not as clear. So think about medicine. Medicine has developed very, very well in some areas and not as much in other areas. And in a lot of ways, it's an art too. So it's not just a science; it's an art. It's not a clear issue tree that you follow. A lot of times, the intuition and the doctor in the back of their mind, they're thinking, this person, they are this gender, this age, probably this demographic, they live in this area, they've been to these places, and intuitively they're computing, it might be whatever, Zika. Right? It's not necessarily a very formal issue tree.
I'm curious on the data piece. How viable do you think the idea is of kind of user contributed data? Like in a decentralized network, I think there's a lot of promise around the idea of, okay, we've already scraped the internet, we're already done with that. Is there a way that we can effectively incentivize people to contribute data that is otherwise not out there that the labs have access to? And blockchains might be a good way to effectively facilitate that kind of transaction.
Yeah. But blockchain I think is a great way to incentivize that transaction.
What are the challenges with like that type of data? Like what would need to happen for that to be usable in a good model, so to speak?
So good data, usable data, I think is privately held. A lot of it, so if you think about privately held usable data is much larger than publicly available usable data. Within that privately held user data, it is not structured or ready in a format that is usable in the same way. You need to do a lot of work to normalize it, to standardize it, to make it actually usable. The way I store data, the way I do whatever my expense tracking is probably different than how everyone around the table does it. So how do you standardize and normalize all of that so that it actually becomes usable for a model? So that's another big challenge. Getting people to contribute. There's a third challenge as well, where a lot of the data, if you think about a lot of the data held by individuals versus data held a lot of data is held by individuals, but even more data is held by entities, companies, hospitals, clinics, lawyer offices, governments, et cetera, and that data, it's actually quite difficult to get to incentivize them. You have to offer them some sort of value add service that involves their data so that they can contribute that. And so the answer to your question is, I think it's going to be a combination with the first part, which is publicly available data or privately held personal data. Yes, Web3 is one of the great incentives mechanisms or supplementary incentive mechanism, but the problem is going to be in the privately held entity data.
Can I make a point here really quick? I think so data is a key component to making good models. But if you cannot monetize at the model layer, there's no incentive to monetize the data, right? And so there's this missing piece today, which is can you monetize there, which makes the input resource actually valuable and this path doing it. Different to okay, you just sign an enterprise agreement and you buy all the data, right? It's done today. So my whole thing is you get the monetization at the model layer to work, suddenly you can actually have market dynamics at that data layer as well.
So that's a really interesting point, right? Because there's a lot of talk about data DAOs and data unions in Web3.
Yeah.
There was even recently a Reddit data DAO that got put together, and they basically said, look, Reddit sold everybody's data for $250 million. That's unfair. We should be able to sell it ourselves. And they're not wrong, but if you do the computation, $250 million divided by 500 million users, your data is worth 50 cents.
Yeah.
Yep.
Right. So, how do you fix that? What implication does that have for the commercialization, Alex? To your point, of the training stack.
I think there's people that are accumulating these data sets today and then sell them to enterprise. Right. There's a lot of companies that do this. They accumulate blockchain specific data, and it's this big structured data set, and it helps make the models better. Right. So I think you have these entities already accumulated, and they already sell it through standard enterprise agreements. But it's open source doesn't really have access to that, because it's okay, well, we'll just give you access for free. That's the pitch, right? Because we're going to make the model for free. And so unless you have this some level of monetization at this open layer where that value transfer can flow back to what I call the proprietary data set assemblers, right? It's not private data, it's just proprietary, right? It's good, clean, structured data that's just not in a public data set already. That's the dynamic that's missing today. It's how can you take that kind of stuff and actually bring it to open source?
And when you say proprietary, you mean individuals as opposed to enterprises?
I think about it as you have public data, which is fine web. It's already assembled. You have private data, which is stuff in a hospital that just can't be leaked. But then you have this intermediate stuff of proprietary, which is it's kind of out there. It's just not cleaned. It's not assembled. It's not packaged. But there's companies today that do that and sell it.
Yeah, most of the work in this public data stuff goes into actually cleaning the data.
Yeah.
Because as Jake mentioned, on average, every user's data is worth actually 50 cents, even less.
Yeah.
If I be honest, most of them are zero, right? And how do you take that and how do you clean them up in a way that it's usable for model training? That's the bigger challenge.
Yeah. I think so. We're experimenting with a different economic model. And the way you think about it, if you have whatever iron core, it's worth X, but you process it and add a lot of components to make an iPhone, and it's worth 1,000X. So the higher the processing, the higher the value. So the economic model I'm trying to experiment with is, I'm not going to sell you data. I'm not going to sell you refined data. I'm not going to sell you collected data. What we're going to do is we're going to look at the end of the value chain, which is an application that actually works. And then if you sell that, then we're partners in this application. But it has to cascade all the way back, because traditionally, I want to build an application. Okay, I need foundational models. I'm going to go pay up front to get that. I'm going to go pay data to get that. I'm going to go pay for compute to get that. But if you shift the model where everyone's aligned towards the end result, the iPhone versus the iron ore, it has collective value for everyone. The risk is distributed and the value is much higher. So the people who contributed the data, instead of getting 50 cents, assuming 100% efficiency in the chain, which is not going to happen, it's going to be whatever, 20 cents probably by the time it gets to actual margin is going to be lower than that. That might become $10 for very, very minimal contribution. That is recurring and is there's recurring more or less in perpetuity. So now the $10 every 3 months, or every 6 months, or even every year, and you're doing this with 20, 30 other models, now that becomes worth something.
The other kind of interesting tie-in to the architecture and like the setup of these networks and what type of devices and hardware that I think this pulls in. If you want to truly enable people to contribute data to the model, I think you have to go fully decentralized and go full consumer grade hardware, as opposed to the kind of intermediate step, which I think is still good and valuable, of kind of going across data centers. I think the true kind of, the scale benefit you get from the more kind of fully decentralized consumer grade plus data center is greater, but you also get access to this data that people wouldn't otherwise, or that you wouldn't otherwise have if the people running the nodes were just data centers themselves. So for example, if you have a laptop, you might run a piece of the training run for this model. You might also click a button to upload a set of data. It needs to be cleaned and processed for it to be workable, but that kind of, to have that kind of vision and have that be a part of the story, I think that's why it's important for consumer grade kind of decentralized hardware to be involved in these networks.
Maybe we can just talk about like the reality, like what data did you guys use to train Intellect 1, and maybe like Alex and Bidhan, what data are you anticipating to use to train or fine tune on your platform? But
yeah, for sure. Like for what we went with for the like first initial one with Intellect 1, right, was publicly available data from like other open source research labs that filtered the data for us, So we put together like a good data mix to have some coding data in there, some reasoning data, as well as like just cleaned internet data, right? So there's this data set, FindWebEdu by Hugging Face, based the highest quality data set right now for pre-training models. Nobody has trained like a 10B at that size with this new data, basically. So that's why we basically chose it, right? So that's what we went with. Maybe to the whole data point on like where I think decentralized networks could come in beyond also like private data, obviously, which is a huge part. I think, one of the things where consumer devices and GPUs with less memory in a sense could make sense right now, even on in like a decentralized network, is by creating a lot of like synthetic data that you can use for your pre-training, right? Like the paradigm of just training internet data is kind of over. So people are generating, or the big labs are generating huge trillions of tokens of reasoning data, right, with their state-of-the-art models. And in open source AI, we don't have like even a 1 trillion token data set of synthetic, high quality synthetic data, reasoning data. And I'm sure OpenAI is training their GPT-5 on like tens of trillions of this data, right? So I think that's where all the decentralized networks could come in, where even like consumer grade GPUs could be used right now to actually generate a lot of the data.
Yep.
well, that's actually like also an interesting point, because I feel like maybe like Gensyn, Pluralis, you guys are thinking in terms of heterogeneous commodity hardware, like how do we train on that? And then you guys at Prime Intellect are more using high-end GPUs. So what do you guys see happening there? Like, are GPUs going to get really cheap, or is it just like consumer grade hardware will become enabled for training and we'll just do more training? Or like, what's your outlook on the hardware market?
I think if you look at it in terms of like price per dollar per flop, for example, that's getting a lot cheaper and will get cheaper into the future. Just with new kind of state-of-the-art NVIDIA cards that are coming out. Interestingly, flops are no longer really the bottleneck. It's actually memory, and you really can't fit much more high bandwidth memory on the chip anymore. And so that's why we have to do all of these crazy parallel techniques. It's primarily the memory issue. And so, on the one hand, you could say, well, the data center stuff will just keep getting better and better and better. We'll keep building bigger and bigger data centers. I think that's flawed for a couple of reasons. One, we're, I think, reaching the limits, or soon we'll reach the limits of the kind of data center hyperscaling kind of phenomena of the last few years. That'll come from an economic standpoint, it'll come from an energy standpoint, it'll come from perhaps a geopolitical one. But there's also the question of like how much better can the chips get at actually processing and moving kind of data between memory and the processor.
So you're kind of making the case that like we might have to go to commodity hardware regardless.
Or we might have to get smarter and more efficient about what type of workloads actually have to be inside of a data center versus other ones that might be, totally suitable to do on consumer grade stuff. Or perhaps just like more commodity grade stuff. It might still be made by NVIDIA, or maybe it's made by AMD, but you no longer have this world where everyone needs to buy the newest NVIDIA chip every quarter that has an 85% margin on top of it. Instead, we realize actually a lot of this stuff can be done on more commodity stuff.
It's interesting though, right? Like if you think about it, for the big foundation model training, there's going to be a bunch of organizations that'll have, maybe 1,000 H100s. So it's not really enough to do a big run individually, right? But what else are you going to do with those chips, right? Okay, maybe you sell them. But if there's a scenario here where it's like, hey, we can like pull this together, and there's like 10 organizations like this that, together we've got 10,000 of these things. Suddenly you have this path to like, okay, maybe they're useful again.
Yeah. This lower-end hardware are the major use case for decentralized training, from my perspective. Like I was talking to a data center owner last week, and they were like, they have this deal with, the chip providers, NVIDIA in this case, because they're the only one. And they can lease these kind of machines, and they're not allowed to resell it for a certain amount of time, like for like 2 to 3 years. But after that, they can resell it. So the ones they can resell, and the price is like way lower than the current chips, are the ones like 3 years older, right? So like there's this like kind of dynamic which is almost artificial, which is created. Like that's what's creating a lot of this like shortage of GPUs in general, especially the newest ones. But what if like, there are some restrictions of reselling the GPUs which are new, but you can do that on the lower end ones. And there's a greater economy there, and the prices are way lower. But like people don't know what to do with those because they are usually like some data centers have like small part of it, like distributed, right? But there's this new use case for this, like you can actually bring this together, which are lower end now, and use them to do decentralized.
Yeah, I mean, I think I totally agree. I think the supply that you get from kind of broadening the scope, that argument has always been there. The difference now is we actually have the means to network those devices together such that they can function more or less like a single cluster. And it's not the same as within a single data center, but that's the conceptual idea, the way I think of it. We now can like network the kind of edge devices together to train or run inference across as well.
Yeah, when I think about it, it's essentially a pricing strategy where I can charge a much higher price without changing the price tag of really reducing you can only sell it after a while, and it's heavily reduced and all that. And I think this creates more or less artificial scarcity.
Yeah.
And the way to address it is to essentially reduce the demand. But how do you reduce the demand? Well, you can't really reduce it lower than what it is today. We just need to slow down the derivative order. We need to slow down the acceleration. So techniques like that, I completely agree. I think are absolutely necessary. Otherwise, the prices of chips are going to be ridiculous. It's going to be an artificial bottleneck. We already have enough bottlenecks with engineering. We already have with data, with compute. We already have enough bottlenecks. We don't need this one.
Yeah, like if you go try to get some Blackwell from NVIDIA, like it's almost impossible at the moment.
Yeah.
But the data centers that have them, and they leased it for a certain amount of time, and after that time, they start owning it. Like they can pay some amount, very small amount, and they own that GPU. So for that, like they're not able to resell between each other, the Blackwell GPUs at the moment, because they're under this contract of lease. But what about the hardware which are 3 years old? They can do that, right? And there are no artificial bottleneck on that anymore. And that's where you can find this real market value, which is way lower than the artificial marked up market that we have on the newer hardware.
Yeah. Do you think there's a little bit of a fashion brand effect going on where I need to have the latest, or it's genuine need?
It's a genuine need, right? They can't lose. The big tech is in an arms race with each other, and they have to sort of overinvest. Like it's I think that's actually their explicit strategy, right? They've said that. Like we can't afford to underinvest here. So it's an interesting dynamic going on.
But I think you're saying as between like the NVIDIA Blackwell card versus an AMD or versus a whatever else, right? Like, is there a brand thing? Maybe a little bit.
I remember like Mark Zuckerberg on Dwarkesh, where he was like, and then we decided to, buy, I forget what the number was, like buy $100 billion worth of. But then we like just doubled it.
Exactly, right? We just thought better safe than sorry. Right? Yeah.
I can share a bit on the researcher side of things there, right? Like they always want to train on the latest hardware of NVIDIA. They have a preference for training on the H100s, even though you can perfectly fine train on A100s right now. At some point, it actually doesn't make sense, obviously, to train on the older hardware anymore. Just also, like how I see the future they're going is a lot of the chips will just not be used anymore just because of the energy consumption, right? Like, it won't be worth anymore to run a V100 in a sense. But you will use a new chip, basically.
Yeah, like Johannes is right. Like, if you think these training runs are costing tens of millions of dollars, and you have a chip that's twice as efficient, okay, and maybe the cost of the chip's a bit more, but like, if you're using this repeatedly, like, it's extremely logical to just have the best one.
I'd love to kind of maybe get your guys' take on monetization in a decentralized training context, because, like, for example, what we've seen so far from open models is that they're actually like quite difficult to monetize, right? Like, you have stable diffusion, for example, but most people can run that on their MacBook, right? So they're not really, necessarily buying that service from an inference provider. And when you have open weights, that's a problem. So how do you guys think decentralized training, how will it capture value?
I mean, I have a pretty unusual take on this, maybe I can share. Like, I think you have this concept of something I'm calling like a protocol model, right? Which is like this model where you have multiple actors training it, but no one actor can extract the full weight set out from this particular protocol, right? And I think this is like a really fundamental property, right? If you can enforce these things being locked to the protocol in some way, and maybe it's like a cryptographic method, maybe it's sort of exploiting some structure of how neural nets work, suddenly you can lock value to that protocol, and suddenly you can monetize these models. Because if there's collaborative training, but there's sort of full weight sets floating around, you can always stand up centralized inference that's going to be cheaper than whatever you're doing in the protocol, right? Because in the protocol, you have to have tolerance to like bad actors, you need to have like this verification, there's going to be overhead. I can always go quantize the weight, stand it up on some centralized chip and serve it cheaper. So this is my framing, is like there has to be a way here to like lock these things to the protocol. And I think if you can achieve that, then you have this path to monetization.
Yeah, like that's basically open source, but owned weights. That's what I call it. Like the model source is open, but as a contributor, like it's an open source contributor, you go in, you contribute some weights, but only you have access to that. So you own the weights you have. And that solves the problem of monetization in a way that kind of enforces the attribution of revenue flow to the person who owns the weight themselves. Otherwise, like you can have all the licenses in the world, it will be out there, someone will just copy and download it, and they'll just deploy it on their own. Right?
So is that kind of like, is that Linux basically? Like Linux is open source, but if you want kind of a full feature distribution you could just use and has the features that you want, you go and buy that from Red Hat or something?
It's to some extent. I think it's even further down the line in terms of the security of the kind of contribution that you make. Like even that, like even in terms of Red Hat, right? You buy the solution, then you have it yourself. And you can be like a malicious actor and go resell it to someone else, all of that. But what we're talking about here is like a cryptographic method where the consumer are actually utilizing all those weights, but they never get access to it.
Technical question, how is that possible?
One of the ways we have solved that problem, or working towards solving the problem, is parameter efficient fine-tuning. It's like you take a base model and you add your own weights on top, but the weights you add, they are not getting added to the base model. It's like an adapter that you're adding, right? And at the same time, we have figured out a way where you don't necessarily have to get access to the whole weight set of the base model. You get access to a small set of it, or the architecture of the model, which is enough information for you to add an adapter. Then you own the portion of the weights. Then I guess Alex can come in, he can add his own adapter on top. He doesn't need to get access to all of the other things here. So he owns his portion of the weights, I own mine, and you own yours. And then Ahmed can come in and he's like, okay, I want to use this thing. So he has to pay because he doesn't have access to all the weights there. So he has to pay Alex, then he has to come to me, and then he has to go to you. And this is one of the efficient ways we have seen that works in the wild AI space, because that's how it exactly works today before we bring in the decentralized AI. Like people take the open source model, they fine tune it, but they keep the fine tuned version private because they don't want to give the weights away. And that opens up a lot of avenue for collaboration. You have your own weights, you own it, but at the same time you can allow other people to utilize it and collaborate with it. I think for us, like that's one of the most efficient ways that I see working.
Anyone else have thoughts on monetization?
I tend to think for the open models, it has to happen at a layer above, more so at the application layer. You could even argue that the closed models were heading in that direction as well, that the kind of model weights and the kind of state itself is not where you monetize. That'll certainly happen if these things tend to commoditize at the frontier, where all these models kind of look and feel and kind of operate similarly. In that world, I think that it's actually a pretty good world for the consumer to end up in, where we don't have like outsized proprietary control by one or two monopoly players, but rather the technology does kind of commoditize. In that world, then you monetize a layer above, like what app you put on top of. And I think people are still willing to pay for that, right? To pay for good apps that are built on top of models. So I don't know that it's necessary to try to kind of bake in monetization so kind of rigidly at the model layer, because I still think people have incentives to create open models because they can monetize above building apps on top.
But what are the incentives for the model builders here? Like then you're talking about like a vertical integration. Like if I want to build an app, then I train the model. But what are some other reasons, like someone would like to train a massive foundation model if they don't intend to build an app on top and they don't intend to do vertical integration?
I mean, that's a business question. Like, I don't know why you would do that necessarily if you can't monetize it.
Exactly. So then it goes back to the big tech problem. Like Facebook is doing it because they have this vertical integration business layer on top. And they're the only ones who has the incentive to do it.
Well, it also creates an opportunity. So if you can figure out such a monetization mechanism, then that potentially could be like a big market, right?
Yeah, that's a very important point, because it comes, especially like think about Meta, for example. What they have is they are building all of these foundational models and all that, but they work their way, like at least in my mind, they're working their way backwards from the distribution. They own a very strong distribution network, and distribution is everything, and that's where you really monetize all the way at the end, right? So if you think about the value chain, they went all the way to the end of the value chain where it's highest multiple of monetization, and then worked backwards. And that's why I think Meta is going to do really, really well, and probably going to win the consumer race for AI apps in general.
I think I totally agree. I think open source, for them, it's not some like charitable goodwill thing. I think it aligns with their business objectives, and that's often the case with open source software, is that it actually does serve to, typically the dynamic is, let's say you have one kind of dominant player in a market, the kind of second runner will open source whatever the thing is as a way to try to kind of break the monopoly hold. Like Linux and Windows is a great example, Android, iOS, Kubernetes, and AWS. There's tons of examples where major kind of players in the space have used open source strategically and have an incentive to keep open sourcing the next version, because it basically weakens the stranglehold that the kind of competitor has. And so in Meta's case, like you said, like they need models to run their business. Like all of the kind of ad stuff, all of the recommendations sit on top of models. They don't want to be locked in to OpenAI or Anthropic closed models. So what do? they put out Llama as a way to basically break the stranglehold that the competitor has, because they need that platform to run their core business. So that's why I think they'll continue doing it. If not them, then someone else, because there's always a strategic reason for open source if you think about it in this way.
Do you think, Jeff, do you think when they get to the proper frontier level, they'll keep putting them out?
I think they're there now, don't you?
No, I mean, if they had like something equivalent to like a GPT-4, would they?
You don't think Llama 405 is that?
I mean, I don't. Not today, no. I mean, it's close, but I just wonder when they're genuinely competing on broad capability, would they continue to compete on openness? Is my question. Especially if there's a scenario where they go, oh, like, we've now deemed certain chats as public data that we're going to put into the model, and we view the licenses as defensible for that kind of thing. But, we can't release the weights for something like this because it has potentially people's private information. So we're going to keep the weights closed, but we'll make the model available through APIs. To me, that's a very sort of feasible scenario.
But Jeff, another question for you, I guess. Like the decentralized training, like massive AI models, who do you think are on the consumer side of it? Who are training these massive AI models in a decentralized way?
Anyone with a consumer GPU.
But who are training the models?
Oh, actually, the training.
Yeah, actually the training. So that's the supply side, right? Yeah. And that's great. Like we can enable lower capability hardware to do all of these big things. But who are actually doing the model training? Is it big tech or is it like open source community?
It's definitely not big tech. It's kind of open source enthusiasts and hobbyists today.
But what are
I
the
think it's
incentives
companies like Prime Intellect and Pluralis and us at Gensyn. And so what's the follow-up question?
What are the incentives though? Why are open source contributors or whatever, they'll come in and they'll have to pay. It's not free, right?
Yeah.
Maybe it's not going to be free. Why would they pay their money, even though it's not that large amount, to contribute in training this? What they get out of it?
Well, some people might do it because they are just hobbyists or enthusiasts, but I think much more commonly they're startups who are building applications on top of models that they couldn't otherwise train, right? So training a frontier scale model over a decentralized architecture, you still can build apps on top of that, and I think most.
But isn't that conflicting? Because I'm trying to understand, that the startups cannot train, then that's why they're collaborating to train a massive model. But why wouldn't they just use Llama 405 instead? Because if Facebook continue to open source their frontier models, that's always going to do better because they don't have to contribute anything to get the weights of the model, right?
I think a lot of people would start with a Llama architecture today, but you still want the flexibility to pre-train your own thing.
Well, there is an economic consideration if I'm building where in the beginning it doesn't make sense for me to try and build a frontier model from the beginning. It just doesn't make any sense. Yeah. I'm going to start with something off the shelf, test, develop the intuition, and then there's a fork in the road. Do I build my own or continue down this path? So it will vary depending on the application.
Also, I would say I think your mental model is kind of like LLMs, which obviously are like the most competitive space right now.
Yeah.
But think about like video or like generative, right? Like video is not really at a place where it is just like super usable in production. It's made incredible progress, but I could totally see a team coming along and saying, I think I could do better than Midjourney, or I think I could do better than like Suno or Udio, right, for music generation, right? Like those are very like nascent areas. And in that case, I imagine them coming to, one of these decentralized networks and just being able to like gather enough resources to build something really competitive, right? And then the ultimate boss is like, can we build something more competitive than even OpenAI?
I see. So they would come to the decentralized network because they can use commodity hardware and it's cheaper to use.
More scale too. If you want to train a bigger model,
it's really hard to do. I would say, from what I've seen, the value proposition is mostly not cheaper.
Yeah.
But the good news is it's not 20 times more expensive. It's more like 20% more expensive. But the value prop is openness, right? It's like it's that barrier to entry that Jeff talked about in the beginning, right? Where, I don't need to go gather like $60 million worth of investment capital from VCs and then burn it on compute, I could actually co-own, the resulting model with a community who's like really interested in, whatever it is, like the next hot video model, and they're really bought into that, and they're willing to fund that, and they're willing to take risk on that. And it's like crowdfunding.
Yeah. This is the key thing, though. This is why I think like monetizing at the model level is just so critical. It's like if you can incentivize with fractional ownership rather than some generic protocol token or just paying for training with fiat, suddenly a model design doesn't have to be rich, right? Like a really good example of this is the Euthla AI guys that trained Bloom a bunch of years ago, right? They went out, they're like, okay, we have this is before GPT, right? It was like a BERT style thing. They're like, okay, we want to train this big model. We know how to do it. We're kind of fringe guys. They had to go raise a bunch of money from like grant bodies, right? Like it's like the opposite of open source. It's like you have to engage with this horrible bureaucratic process, and then they train it, and then it's good, and then there's like another model that comes out, and okay, well, what are we gonna do now? Like raise more money? Like, no, they just stopped, right? So I think, yeah, you want to give these people that don't have access to very large capital pools the ability to simply just be convincing to compute providers. Like, look, I have the ability to turn this like raw compute into something that in aggregate is worth more than just the cost of the cycles. And you can bet on that, right? You can sort of say, okay, Euthla, they're proposing this run. This is like very interesting. I don't know if it's going to work, but if it does, it's pretty cool. I might sort of contribute some compute to that kind of thing. So I view the core of it as this monetization at the model layer. And if you can achieve that, you sort of introduce a new economics to this layer, which is lacking today. Exactly.
Yeah, open is great, but when you take open and add monetization on top, it just gets supercharged.
Well, I think the whole thing is like open source AI is just fundamentally different to open source software, where it just has this huge cost. And people are like taking the dynamics of open source software and they're like trying to map it onto open source AI.
It's not working.
These are fundamentally different processes.
Right.
Like one is the donation of huge amounts of money.
Right.
And so we actually need a different system here.
Yeah, I agree. And I also think like the decentralized AI training is massively important. What I don't agree with, I forgot who made the point. What I don't agree with, that I don't think Meta will keep open sourcing their frontier models and continue to do so. That's not going to continue happening.
I think Mark Zuckerberg pretty much said that on some podcasts. I want to dig into another issue with you guys that I think is at the core of like this space being successful, which is not a technical issue. It's more a social issue, right? So as long as I've been in Web3, I've always thought of like Web 2 and Web 3 as kind of converging together. Mm-hmm. And there's a special case of that. Web 2 AI and Web 3 AI are two very, very different like sets of people that are currently in the process of also converging together. I feel like Web 2 people who work in AI, a lot of them are highly trained. They're from academia. It really matters what school you went to. It really matters what lab you worked at. They're very used to the Web 2 business model. They're very used to the Web 2 way of creating software. In Web 3, we have a number of people who are like on the frontier of open source, who are pretty scrappy historically, right? Some of them are amazing technologists, but they love to like get into stuff at the last minute, right? So maybe they didn't have a PhD in AI for the most part. And one thing about crypto people for sure is they like don't care as much about pedigree, where you went to school, whether you went to Harvard or whatever. And so on top of that, there's also been skepticism from Web 2 folks, like here in this city, that like Web 3 is even a thing, or it's like worth working on, right? So how do we converge? Like, how is that going, the convergence between Web 2 AI people and Web 3 AI people, from your perspectives on the customers you're talking to, the researchers you're working with, and maybe Web 3 people as well. So what do you think?
Yeah, I've been thinking about this, I guess, forever. Like, how do we get these Web 2 people and bring them to the Web 3 AI world, right? And one of the things when you look at like historically, like just forget about AI for a bit, like look into Web 3 in general. Like, what are the Web 3 products or protocols, whatever you call it, which got the maximum amount of PMF within the normal Web 2 people, without the PFP, like NFT PFPs, they're the ones which created the most Web 2-like user experiences. And they use the power of cryptography underneath and decentralization and Web3 underneath to supercharge whatever distribution they wanted to get. Like all the consumer apps, like the look at wallets, look at protocols, whatnot, right? And then map that back to the Web3 AI. I think the best way to do it is that see what the Web2 AI developers are doing today and replicate that workflow with using cryptography, using decentralization. And one of the things, for example, we did was we looked into like what are the developers doing today in open source AI. They take an open source base model and they fine tune for their own use cases, like use proprietary data and whatnot. And they generate revenue from that. And what if we can take that and replicate that exact workflow, but use cryptography to allow for ownership and privacy for their weights and whatnot? This is harder to do as well because you can just go somewhere and ask people like, hey, you have to rip off your whole workflow and do this totally new thing, which is amazing. But what if you can tell them like, you can do exactly what you're doing today, but you have this like cryptographic monetization layer on top, which gives you like another additional revenue stream. That's hard, but those are the kind of approaches I think will win out the Web2 AI developers.
So new business models.
Yeah.
New business models, but using the same workflow, like give them the familiar experience they have today.
Yeah, I think we need to support and focus on things that add value. And what I mean by that is, if you think about those spaces, so Web3, AI, Web2, full of very, very talented, highly specialized, highly motivated people. And when you're that kind of person, you develop expertise in your area. You tend to go deep. You tend to find you have a hammer and every problem is a nail. So you're trying to add Web3 to everything, or you're trying to add AI to everything. Not everything needs this or that. There are good applications and bad and not so good applications for each one of the use cases. Now, the thing is, the other component why this is difficult is clickbait and the things that capture media attention. It's rug pull to the moon, all of these things. So it actually distorts the reality of what it actually is, because these things are, it's super interesting. Oh, damn, look at what they did.
And it's louder too.
It's just much louder, right? Yeah. But the reality is this is not what Web3 is about. And AI isn't about gimmicky stuff either. And Web2 isn't about that dot-com boom. It's not what it's about. So I think focus and come together. What I mean by that is, if we stop thinking about it, this is Web2, this is Web3, this is AI, and stop putting it in buckets and just focus on the end problem. What is the problem that we're trying to solve? What is the best tool to solve this, regardless of our individual domains? Now, the boundaries don't matter anymore because you're trying to solve a problem. You have a purpose, you have a mission, and you're not trying to sell a Web3 product, you're not trying to sell an AI product, you're solving an answer to a customer pain. So at that point, it doesn't matter what are you using, a brown cup or a red cup. I'm solving the thirst problem.
What problem do you think meme coins are solving? Because they're getting adoption, so there's that. Like the
dopamine
need for
and
gambling.
adrenaline.
Yeah, true. Yeah, I agree.
I do agree with like the thought though, because I don't think that this is going to look exactly like the kind of prior way that ML has been done for the last 20 years. I think it will look different. There will be different types of models that flourish in decentralized networks versus just trying to kind of port over the old architectures onto a decentralized network. That doesn't typically work well in crypto. And I'm remembering back to, if you think back to like early days of DeFi and the stuff that has actually worked, things like Uniswap or MakerDAO, like they don't really look like the kind of Web 2 analog, like the kind of traditional TradFi analog. They look different, they do different things. I think it will have something similar here where the real breakthrough things will be native to this type of space. It won't just be kind of porting over the way we're doing it previously.
How do you guys think decentralized training will be adopted?
I'll go first. At the end of it, I think decentralized training will be adopted, decentralized AI in general, not by the the Web3 degens that we talk about, but by the actual Web2 AI people who are doing stuff, like we're building things. However, we might disagree, like what they're building, how the value accrues. But those are the folks who will be adopting that at the end of the day.
Yeah.
So one interesting thing, right? You can see there's this emerging application layer in crypto, right? And it's like you have this whole agents layer and stuff like this. And as today, that's fine when we have Llama 3, and you can sort of build on that. But what happens if we don't get Llama 4 or Llama 5? And what happens if OpenAI and Anthropic say, we really don't like our stuff being used in these particular use cases, right? And we're just going to put a blanket ban. So I think there's a potential for like a lot of adoption in that kind of a scenario.
Sorry, go ahead.
I was just going to say the last point is what Johannes said at the start is like, you can really assemble more compute in these protocols than you can in a centralized case. And so while I think at the start you have all these sort of maybe niche, narrow use cases where there's genuine demand, the terminal state here is you can generally compete on broad utility because you can train the biggest models this way. And I think everything is just the path to that outcome.
Very much agree with like the long-term future there. We're going to train the biggest model in that fashion, right, over the long term. I think there's a lot of like intermediate like points where decentralized training is going to have adoption, is going to add value in a sense for like a lot of like public good funding and stuff like this, where people just want to come together, train a model together in different domains, right?
You even see in Llama, like the Llama subreddit where people are like, if this works, like I'm going to go buy 3090 now, right? Like the latent enthusiasm for it is really strong.
Exactly. I think that it's going to be important. It's going to be on the scientific foundation model front where we're going to be releasing some stuff. It's going to be, video, audio gen, all those kind of models where you could train right now a state-of-the-art model, as well as with language models where you are still at a smaller scale, but even there, nothing is stopping you right now from training a state-of-the-art small language model in that fashion.
I'm going to pick up on the thing you mentioned about agents, because I actually do see that as a very meaningful and perhaps the biggest future source of demand for this stuff. You could imagine an agent that effectively is carrying out some set of instructions or operating in some way to serve some person's goal. That agent is going to need to continually fine-tune its underlying model. And so it's no longer the case where we have, we pre-train a model, we kind of pull it off the shelf, and then that's it, you just run inference on it. I think in the future, we'll have more of a continual learning paradigm where new data is sourced, the model needs to continue getting updated in real time. And if it's an agent on top of that is directing that training, that is better served being on top of a blockchain where all of this is programmatic. It can have access to a wallet. It can have access to tokens to make payments. It doesn't need to sign up for a bank account. It doesn't need to sign up for AWS credits or something. All of it can happen in the same ecosystem because it's all built on the same substrate. So I see that as the most exciting kind of future source of demand.
Yeah, so I do have one. I see the future as very bright. there's one scenario I think that we need to work really hard to avoid. First of all, like if you take away decentralized, if you take away open source altogether, if the big tech companies decide to take away open source, this will accelerate the need for decentralized open source. It actually will fire back massively. So I don't think it's going to happen soon. I think it's going to be slow. They're going to boil the frog essentially, right? So that's the first part. The problem is that, or the scare, not the scare. The future I think we need to avoid is to have the open source and the decentralized actually sponsored and guided by the same big tech players. So React.
Interesting.
React is it's free. It's great. I love React. I'm sure you guys use React.
I don't. But
Good for you, man. I'm happy for you. But it also gives Meta a significant amount of leverage, right? Even though it's practically open.
Yeah, true.
But it's a significant amount of leverage.
Yeah, same way like Next.js is for Vercel, right?
But I have a question on it, because this is a common thing people say, right? It's like, okay, Llama, we're going to build this ecosystem around these open models, and this is like a strategic thing, and this is not a high conviction thing for me, I'm just throwing this out there. Like, I feel like there's significantly less to build around these models than there is for something like React, where you genuinely have this like big ecosystem around it, and you have this developed mindshare. Like, to me, the switching cost of a base model is nothing. I interact with one model the exact same way I interact with another one. I can switch the API out extremely easily. It's like totally fungible. So I just wonder, like, do you guys think these dynamics are actually the same?
So do you think it's easier to switch for foundation models than frameworks like React?
Exactly. Or even example like, like database. Like, think how hard it is to switch out like an actual database, right?
Yeah, that's true. We have been trying to get out of React for a while, but it just takes a lot of time.
It's extremely difficult. It's extremely sticky. Whereas you want to switch between it like ChatGPT and Claude. It's not hard.
Like the prompts and all the structure of like instruction they take, like they are different, right?
I mean, not that much.
Yeah, it gets harder the more you're invested into one model. So the more you invest, the further down the road you are, the more difficult it's going to be to switch because you need to redo some work.
Yeah,
Like what?
The ones you go into chain of thought kind of stuff, right? Those stuff, that's not just one prompt. That's like a chain of prompts and how you react to the decision tree, right? And whatever base model you're using kind of changes the whole decision tree, right? So it's probably going to get like a little bit more complicated.
Yeah, it's still a lot easier than trying to get off React.
Yeah.
Right?
Yeah, I know. We have been trying.
I think the main point
We're
is
not even trying.
more on the engineering infrastructure and the architecture of the model that is actually there, right? That all the libraries you basically use right now, right, coming from anywhere else are actually optimized for the Llama architecture, for example, right? So, for example, we've been training a scientific foundation model, right? And it has nothing to do with natural language text in a sense, right? But we still went with the Llama architecture just because people will have a way easier time to run this in Llama or any like local inference code base without changing anything, right? So I think that's one of the arguments there. But I otherwise would agree with you. Less switching costs than with a React framework or whatever.
Awesome. Well, guys, I think for this last part, maybe let's go around, and I'd love to hear what are your predictions for decentralized AI, let's say next 12 to 18 months, and any parting thoughts you have about our discussion today or what you guys are doing at your companies. So Bagel, Prime Intellect, Gensyn, Kiva, Pluralis. What are we going to see in the future over the next year and a half?
Yeah, I mean, I think we're going to see a bit of like an academic tipping point, sort of in the next year and a half, where this awareness that there's like actually really genuine, interesting, hard technical problems here, that they're solvable, that like sustained effort can actually make progress here, and lead to an outcome which is like extremely significant. It feels to me like that's sort of going to happen very soon. There's already these trickles. There's like a few papers. There's Max Rubin's work. There's DeLoco. These are like serious people at serious labs. Other researchers look at that and take it seriously. You know, us at Pluralis, we're going to start publishing some stuff soon as well. I think it's gonna go mainstream in like the AI sort of academic world, and we're really interested in collabs, right? If there's like people out at big, good institutions that like want to work on these problems, we're very, very interested in working together with people to solve this. I think the problem service area is huge. I think there's going to be hundreds of papers on this kind of thing, and it's very collaborative in nature. So we're looking to do that.
Yeah, I think a lot of the bottlenecks are going to start shifting because we have the same bottlenecks over and over again. It's just going to rebalance again. So some of the bottlenecks are going to move from compute to engineers to foundational models to data, et cetera, et cetera. So I think the bottlenecks are going to continue shifting just the way they did in the past. And I don't know which one is going to be next, but if I were to bet, I would say, and I'm biased obviously, but I'd say data, because it's one of the key differentiators of how a model actually performs and who has the data. Because the next bottleneck is not going to be who has the models. You can access some models, right? Hardware, yes, I know you have to put in, compute, you have to put in quite a bit of effort, but you can find it. But data, if you don't have it, you don't have it.
I would say, I think we'll have a highly performant model that is trained over a decentralized network in the next year. I think it will probably look different, though, than what people expect. I doubt it will be a dense transformer that's just like pipelined across a decentralized network. It might have a different architecture. The training method will be different. It might be more like a swarm or some evolutionary algorithm or a search style algorithm. And I think that's really going to open people's eyes in the research community.
Hey, that was going to be my prediction. Transformers are dead. Okay, now I have to think of another one.
Yeah, pretty much agree with your statement. I think we will train a state-of-the-art model in the next 12 months in a decentralized fashion, basically, over a decentralized network. It's going to be bigger than what we had with Intellect 1, right? It's going to be a 10 times scale up or something like this, right? So in that regime, we're going to train a state-of-the-art model, as well as make progress on like all the other dimensions that are actually needed to get this done, right? Like large-scale synthetic data generation, I already mentioned that before, right? So it needs to be done to actually get to the next frontier, have huge ton of like reasoning data, right, to get more into this like O1 type pre-training regime, right? I think that's going to happen in 12 months. And yeah, obviously also looking for collaborators and research engineers and all those things.
I think there has been a lot of talks about privacy and verifiability in decentralized AI, which is not scalable at the moment. They're super slow. Some of them have a lot of like use cases, but they don't work. And within the next 12 months, within the next 6 months, we'll see solutions emerging, which are actually scalable and gives you actual privacy and verifiability from the context of decentralized AI. And it's going to be open source as well. How do I know? Because we're working on it as well. And we'll open source it for the community. And it's going to be great, like Donald Trump says.
Guys, after this roundtable, I think I'm like the most bullish I've ever been on decentralized trading, and I've been pretty bullish on it. So thank you so much. My prediction is that we're going to have decentralized AI summer 2025. You heard it here first, and I'm looking forward to seeing all the incredible progress you guys are making in this field. So thank you so much for joining us.
Thank you.
Thank you.
This was fun.